Today we start part D, binary search and selection problem. Here you can see we will solve two basic, relatively simple problems. The first one, the well-known binary search. The second one, selection problem. All right, the first one, part D.1, binary search, elimination. This means the way we do the binary search, we will use this important problem-solving method called the elimination method. Very simple, pretty natural, and very useful, very effective. All right, so this idea so important. Yeah. So we need to spend quite some time to learn elimination method. All right, so let's look at the question first. The question, our problem number 12, search an ordered array. This time, I emphasize this ordered array. So the data is organized, well organized, ordered array. Yeah. So that is very important property. So we should take advantage of it. All right. The question, given an ordered array like this, and a search key V. The question, how to find an index I such that V equals A of I. That's simple. Okay, yeah, the problem is very simple. Now, let us do the analysis. First, let us look at the idea, main idea we want to use here. Reduce the problem size. Yeah, so here you can see the general problem solving in this class. Most of the time when we solve a computing problem, we try to reduce the problem size. Yeah. The smaller the problem size, the easier the solution. So that's simple. Yeah. Here, let us look at how do we do that. Yeah. There are many different ways to reduce the problem size. Yeah. Here, we want to use the ordered data property. Ordered data property. Yeah. So this property is critical in our solution. Yeah. Why? So here, let me go another step forward. Why using the ordered data property it can help us get a good solution? Yeah. The reason is very simple. Yeah. The reason is we can make good prediction. Good prediction. Yeah. Ordered data. Yeah. That information can be used to help us make very good prediction. Or in other words, yeah, sometimes prediction, sometimes decision, right? Yeah. Good prediction and sometimes, yeah, prediction, something unknown, right? Yeah. But sometimes you are pretty sure the decision is here and there. So, and a good decision, not just prediction. Yeah. When you make decision, you can make a very good decision. Yeah. Also. Okay. Yeah. All right. So that is the reason this elimination method is very effective in this situation. All right. Okay. Let's continue our further analysis. Question, how can we take advantage of the ordered data property? Yeah. Now we need to use this property. Yeah. How to use this property? Let us look at the next analysis using diagram. Yeah. Explore the ordering property. Yeah. let us draw this diagram. So we have this ordered array. Yeah. Next, the given key V, we can use it to compare any element in the array. Yeah. Any element based on its position in the array, when we do the comparison with it, we may get different results. Yeah. Here we want to look at that part. Yeah. We want to look at the possible results after each comparison. All right. Here we may select some special cases and compare which one is the best. The first case, we compare with the last element. Okay, it is an extremal case. Second, we compare V with an element somewhere in the middle. So it's not an extremal case. Yeah. So, pretty much average case. Yeah, pretty much average case. The second candidate. Okay. The third one, another extremal case. Left extremal element case. But left, right, pretty similar, right? Yeah. So we only need to pick one of the extremal cases. Yeah. Here. So let us do some experiments and see what happens. Question. After one comparison, how many elements can be eliminated? Yeah. So this question is very important. How many elements can be eliminated? Yeah. Here, what do you mean eliminated, right? Eliminated, very simple. If you can decide certain number of elements out of the consideration, yeah. So the given key V cannot be any one of that group of elements. Then that group can be eliminated completely. Yeah. So that's the meaning here. Here we want to see how many elements can be eliminated. Yeah. After one comparison, our goal, we want to eliminate the maximum number of elements. All right. So that is the goal. All right. Yeah. Here, let me put here. Goal, eliminate maximum number of elements. Yeah. Let me put here number of elements. That is our current goal. All right. With this goal, let us look at the first experiment. When we compare V with the last element, there are two possibilities we need to consider. The first one, the best case. Okay, yeah. V greater or equal to A sub n minus 1. Why we say this is the best case? Because we can make our conclusion immediately, right? Yeah. If V equals A sub n minus 1, we find it. We find the element we want, right? But if V is strictly greater than A sub n minus 1, our conclusion also pretty straightforward. V does not appear in the given array. Does not appear in the given array. We do not need to look at other places because here we use the ordered data property. The ordered data property tells us after this comparison, if you get this result, you can make your decision. So here, this is a decision situation. Your decision, you can eliminate all the elements in the array. So here I'm talking about strictly greater than case. That's elimination. Yeah. All right. Yeah. Other cases, then when v less than a sub n minus 1, then you need to consider many subcases, right? After this, yeah, because after this comparison, based on this result, how many elements can you remove? Or can you eliminate? Only one. The only element you can eliminate, that is an minus 1. All the other elements, you need to consider, right? Still, there is a possibility v could be one of the other elements. Now, so look at these two experiments. These two experiments, what can we get from our current experience? Can you see something interesting helping us find a solution? Yeah, here. I want to mention a well-known law. It's called Murphy's Law. I think you heard of it. Yeah, Murphy's Law. Yeah, just one sentence describe it. Anything that can go wrong will go wrong. All right, Murphy's Law. Yeah, Murphy's Law. All right, so I do not need to explain this Murphy's Law. Yeah, because there is a thick book talk about Murphy's Law. So here, I just want to use this. Our thinking, we need to based on at least part of Murphy's Law. Why? Because this is, we can call the worst case, not the worst, worse than the best case. Okay, yeah, worst case, yeah, not the worst. Okay, yeah. So this case we treat as something go wrong. So go wrong, we understand this way. We will get relatively worse solution. Okay, relatively worse solution. That's something we match that go wrong thing. Okay, go wrong thing. All right. Then we may have worse case. Then we have to consider, we have to put our focus on that possible worst case. Worse. All right, yeah. So that means this is our main concern here. Main concern here. All right? Yep. Okay? Yep. Only one element can be eliminated. That's not good. All right. Then let's go to the next step. Yeah. In order to get a better solution, what is our strategy? Okay. Here there is another very useful strategy in problem solving. Okay. It is about when you make a decision, which decision tends to give you best or a good solution. Yeah, that is balancing principle. When you make your decision, try to make the decision that is as balanced as possible. Balance. So here, balance. No. Yeah. On what is the exact meaning of balance? Balance here. Balance here, it means when you distribute your data, you distribute your data in a balanced way. So that's the meaning. All right. Compare the one right in the middle here. When we make the decision, we choose the element right in the middle. Why right in the middle? Because that is the most balanced decision. Yeah. Why when you select element right in the middle, it is the most balanced decision because the data at its left-hand side approximately 1/2 of the size, and the data at its right-hand side also approximately 1/2 of the data size. So that is a very balanced decision regarding the data, the given data. All right. Yeah. So compare the one right in the middle, and we call it the median. The median. So what is the median? Yeah. So we heard of this term many times, but here the exact meaning of the median. All right. Given an array, what is its median? First, you assume when the array is sorted. Yeah, but the given array may not be sorted, right? But when you talk about median, you need to assume when the array is sorted, the element in the middle position is the median. Yeah. But sometimes some students may ask if we are given even number of elements in the array, because there are two elements right in the middle. Yeah. In that situation, yeah. So let me explain that situation. In that situation, actually, we have two medians, one left median, another right median. Okay, left median and a right median, two medians. But by default, the left median is the default median. Yeah. So when we talk about the median of the array, we refer to the left median. Okay, not the right median. Yeah. If someone really wants to take the right median, he or she needs to explicitly say the right median. All right, otherwise we just take the left median. All right, yeah. So now we compare the given key with the median. Yeah. Every time you can throw away 1/2 of the elements. Yes. So this is the result. This is the elimination result. Okay? This is the elimination result we can enjoy. Yeah. We can throw away, we can eliminate the maximum number of elements. Yeah. And we can easily see this decision is better than other decisions. This decision is better than other decisions. Okay? All right. Yeah. I just draw a simple diagram to show this median-based comparison can give us better result than any other element-based elimination method. Yeah. The reason is, suppose you pick an element, not a median, so you will get two part of the data that are not balanced. There is a bigger subarray and a smaller subarray, right? Yeah. Bigger subarray, smaller subarray. Then, when we consider the elimination method, you need to put your main focus at the larger subarray part. Yeah. Because, based on the Murphy's law, you need to worry about the worst case, not the better case, or the worst case. So, yeah. So you need to worry about only this small subarray is eliminated. The larger subarray may possibly contain the given key. In that case, the part that you can eliminate less than 1/2 of the data size. Less than 1/2 of data size. But based on our median-based elimination, every time we eliminate approximately, may not be exact, approximately 1/2 of the data size. How about that? 1/2 of data size. That one is less than 1/2 of data size. Which one is better, right? Clearly, the median-based elimination can give us the best solution. So this is the best solution. All right, yeah. So that is the elimination. All right, so we finish our D.1 video right here.